first 5 terms of a quadratic sequence are 6, 10, 16, 24 and 34. And I need to show that the nth term of this sequence is n squared plus n plus 4. So we are first going to work out the first differences. The difference between 6 and 10 is 4, between 10 and 16 is 6, between 16 and 24 is 8, and between 24 and 34 is 10. We're now going to work out the second differences. The difference between 4 and 6 is 2, 6 and 8 is 2, 8 and 10 is 2. So the second difference is all the same. So it's a quadratic sequence we're looking for. So we know it's going to look like an squared plus bn plus c. I know that this term here is always equal to 2a, which means that a has to be equal to 1. I know that this term here is always equal to 3a plus b. And considering that we've just worked out that a is actually 1, 3 times 1 is 3, plus b is equal to 4, so b is equal to 1. And then we also know that this term here is always equal to a plus b plus c. We've previously worked out that the a is 1, the b is 1, so 1 plus 1 plus c is equal to 6. 1 plus 1 is 2, take that away from both sides and we find that c is equal to 4. So therefore my nth term is an squared plus bn plus c, and strictly we don't really need these ones, we could just say n squared and n. And that is what we needed to show. For part B it says hence determine whether 136 is a term in the sequence. Well, if 136 is a term in the sequence, then n squared plus n plus 4 should equal 136 at some point. If this equation has an integer solution, because there has to be a whole number of terms, we can't have a decimal term. If there's an integer solution to this, then we can say yes, it is in the sequence. If there isn't an integer solution to this, we'll say no. So let's see, let's solve this quadratic equation. I'm going to do so by subtracting 136 from both sides to make this equal to 0. So 4 take away 136 is minus 132. Now we'll factorise if we can. If we can't, we can always use the quadratic formula. But I think this will factorise because we can have, that's going to be 11 times 12, I think. And it's going to be a minus 11 and a plus 12 to give us the, so the minus 11 times 12 gives us the minus 132, and when we do the minus 11 plus the 12, we get the the plus 1. So that works. That's been factorised nicely. So now we can say that either n has to equal 11 or n has to equal minus 12. It doesn't make sense to have a negative number of terms in the sequence, so we're going to neglect that one here. But n equals 11 is a valid solution, and so we can say yes, 136 is the 11th term in the sequence.